So hi everyone, welcome again to my YouTube channel Fitness Freak Computer Geek. In the last lecture, we have seen about some formal definition of pointers. We've seen some points on pointers, how to actually define pointers in some formal terms. This lecture is completely based on coding part, where I will show you some coding example of pointers, which will give you some deeper understanding of pointers, how it actually work in a system. Okay, so now we will see the practical approach of pointer. So without wasting any time, let's begin. Let me just first show you how to do it. Remember this code from the last lecture. If you remember this code, and last lecture I have discussed in PPT about this code, and now today I will show you the practical example. Okay, so it is better to understand anything by coding, programming. So before going into that, let me just show you some simple example. So I will just declare one variable int I and have some value something, and I will declare some pointers here. I will declare one pointer here. If you remember how to declare pointer, that we use asterisk, which is mnemonic, asterisk of y, which will keep the value of address of I. So it will now point to I. So what does this mean? Means y is a pointer variable, and I normal variable. Okay, just like we declared, and in this line means that y is pointing to I. So whatever the address of y, suppose y is 100, address 100, so it will also store the value of address of 100. So it's pointer variable. Pointer variable is, remember that recall that pointer variable used to store address, and I will have 5. So this is how we're gonna do. And now and in that program I will use some print statement to show you what will the output of something if you write something here in a different way. Okay, so let me just, before going into that, let me just get into this topic. Okay, so it will give you deeper understanding what I woke up. So now let me just hop into my code block. The code block is here. So now let me just Control Shift N for new file and save as, Control S as, save it at YouTube channel code. Suppose I am just any pointers. Okay, so pointers 1.c, save it as C file. So first of all, as usual, just include the header file and start coding. So first of all, what will we do? First of all, I will declare one variable as I discussed in the example. So let me just keep value 5 and just declare one pointer variable, okay, y, which will contain the address of x. Okay, so it's cleared up to it. Now just print the value. So first of all, let me print percentile d value of x. So it will, what will it do? It will just print the value of x. Okay, so it is very it must be clear to you guys. So let me do it. So just print this value. What will this output? You all know the output. Let me just run it for you guys. So you can see the 5 agent printed here. Okay, so now what if I just write in another line, printf percentile d value of y. So what do you think this line will output? Okay, so pause the video for a moment and think about it. And so you might have now come with the logic. So it will actually print. So you can see the 5 agent printing. Okay, let me just put the new line here. So now let me see what it going to output. So run it. So you can see 5 values printed. Okay, so now you understand that these two things are same, both are same thing. Okay, which I have told you. So what is actually happening here? Okay, so for clearance, let me just show you what is happening here actually. So I value suppose, yeah, so it is the first line says a printf I value, so it is as usual, just print the value what is present in I. The first line is clear, but the second line say that, just see this second line say that value at y. What is the meaning of this? So this means that value at y means value at y tag contain the address of x. X has the address of 100. So value at, this implies value at 100. So value at 100 is what? 5. Value is printed again. So our output is 5 and 5. Okay, so hope you get this now. Now let me show you some other interesting thing here. So now let me just do something else. What if I just use here something percentile used for unsigned integer and just print the y value? So what do you think that this is going to print? It's very dangerous thing actually. You will understand that now we are dealing with pointers actually. Now we are dealing with the entire address, which is done by operating system, which is a Java operating system. Now we, with the help of use pointers, as I have discussed with the help of pointer, we are dealing with the memory by ourselves. So as I have told you in the first lecture, the whatever the things are done by OS operating system, our operating system will also can be done by our user with the help of an aid of pointers. So now let me see what will it will print. So you can say something random value. It is actually you can the address in which y value is assigned. Address of y means this actually means this in operating system you will have some memory. In the memory y value will be declared somewhere. If somewhere near y is declared, and its address is let's just now we have seen. Okay, let me just run it for one at a time. You can see this address. So what was I trying to say, that the y value have been declared and we will assign this address. Okay, it is randomly assigned by operating system. Okay, but you can now you can see, although it is randomly assigned, we can use this address. This is the most powerful languaging tool that is used in C or C++. That is pointers. Now you can understand the power of pointers. So now moving on, let me now just do one more thing. Okay, what I could do percentile u slash n, the value of x means value of address of x. So let me just do it. Let me see what it will return. So you can see it is returning the same value. Why? Can you guess the reason why it is returning the same value? Actually because we are y is pointing to x which has address of x. Now in this line you can see, in this line I am declaring y as percentile u y, which means the value of y. Actually this is mean value of y is pointing to x. So y will have the address of x. So address of x is not, this is not the case here. Okay, sorry for it. It is x value actually. X address of x means x variable have this address, and y will have some other address. Okay, so how to get the address of y? Use the ampersand sign. So in this case x will also have 6420222036. It will the address of x actually. Address of x. So it is address of x actually. So y is pointing to x. So y will have the value of address of x. Y will contain value as address of x. Okay. So hope you are getting it. So now how are you gonna display the address of y? Will it return the same value or different value? So now let me just print this. Okay. Now let's see what value we are getting. So you can say it is dealing with some different value now, and you can also see the value has been changed now, because every time we are running the code, it is being allocated in different part of memory. So it may or may not give the same value. It may be the case that whenever we call the program for second time, it again allocate the same space which is allocated when the program is called for the first time. It may case. So you can just understand here that it will give random value here. Okay, whichever part it can allocate its value. Operating system can allocate the address to a process in anywhere. Okay, we can say the most important point here to be noted is address of y is something else. Okay, so why this is, that y will have some different address. Actually y will have some different address, and which will be different from x, because y and x are different variable. Y is just storing the address of x. Okay, nothing else. Okay, so now hope you are getting this point. Now moving on, now let me just describe this code. Okay, so these were the basic of pointer we must understand to understand this code. Okay, it will be very easy. Okay, don't worry. So now what could be the output of the program? We have seen the output of program PPT. I have shown you the last day, so I will not go into that. Now I will directly define this code. Okay, so we will have three variable x, y, and z, which is an array, and just declare one pointer. I will declare one pointer and assign the value of x. Then I will print it. Then again I will do this. Then print it. Then again I do print it, and then again do this and print it. Okay. By using this, it will be all clear to you guys. Okay. So now let me just do it. Code block now. So let's erase this. So first of all, int x equal to 1 and some y variable and some z variable, which is an array of 10. Okay. So y equal to 2 is also there. Y equal to 2. So this is, and now I will declare one pointer here, which will have the address of x. So we could just printf percentile d. So remember this notation, percentile d and percentile u. Percentile u is generally used for address part, and percentile d is for integer part. So if I just use percentile d here and write, what do you think it will give? It will give the address of x or the value of address of x. So let me see that what is going to return. You can say this is returning address. So explicitly returning, you have to use the ampersand operator, star operator here. Now you can see the value of x has been printed. So this is the we should remember that we should not do it. Okay, so careful while dealing with pointers. It may lead to deadlock in a computer, collapsing of a computer. So it's very essential to keep in mind and focus whenever you do coding in pointers. Okay, so this line is clear. Now what does next line say? Just make y equal to value at ip. Y equal to value at ip. So what will it do now? If I just print here printf percentile d value of means y, just y. Let me see what will it print. I should now print y. Okay, sorry, I will p. Sorry. So you can see the y value is also printed or 1. So hope this is clear to you now how it is working internally. I'm giving you a live example now. And next part is make value at IP as 0. Now value at IP as 0. Now IP will point to a to value 0. Means P. Sorry, I'm taking P here. IP is, so if you just printf now, printf percentile d slash n, print the value at P. So what do you think that it will return now? It will return 0. Let me show you. Okay, what is actually doing? Value at IP is becoming 0. P will value of IP must be 0, but it's not working actually. You can see the error here. Line number 10 here. Printf it is not printing actually. It's becoming making the pointer as 0 variable. Okay, so compiler is giving error here. Okay, actually it should be 0, but something wrong here now. Something not right. Okay, because everything is going fine. Okay, so this is the case. You can understand is now this pointer becomes 0 here. Now let me just give the last value. Now make p as address of z of 0. Okay, so it will now p will point to address of j. So just make something here. J of 0 make it at 9. Now printf percentile d slash n value at p. Okay, let me see what it's giving. It is giving 9 on now. Okay, so it is wrong here. I have to delete this line actually. Okay, so you can see the 9 is printed. Okay, so you cannot make pointer at 0. Now I'm getting the point here. Okay, so you can see in this way the whole code that I have explained in the PPT is there. Okay, so hope this make you more clear about pointers. Okay, now it will give better idea about how the pointer actually work. So now moving on, now let me give you some brief idea about pointers arithmetic, which I am discussing from the first class. So why it is necessary to declare here integer variable? Because already now you can use void here, but why we use int star or float star or something? Now in this lesson it will clear to you. Okay, now suppose let me just first give you the code here. It will give better understanding, but let me just give you some logics here what I am what I will do. So suppose I declare here integer variable p, and suppose I declare here int x equal to 5. Okay, so if I do value at p plus plus or value at p plus, or it will not be visible. Okay. Value at p plus plus or I do value at p, is there a difference in these two terms or not? First let me just clear. Let's just clear it here. Okay, so you should also do here p equal to address of x. So now let me just give you this code. Okay, let's see, print this both the value and let's see what the difference coming out and do accordingly then. Okay, so just erase this part, no need. Suppose I declared integer x here equal to 5 and the int value int star iptr, suppose iptr equal to address of x. Okay, it's clear now. Now I do this. First thing I will do st of p value at p plus plus, and now see, let me just print out the value percentile d slash n value at not p equal to iptr. Sorry, it's very confusing. Sometimes variable name is confusing to you. So this is the case here. Okay, so suppose I want to print the value of iptr. How are we gonna do it? So what will it do? Hello iptr. So first of all just print the leave it here. First of all just print the here one more thing, printf percentile u slash n. Suppose I print here address of iptr. So what will it print here? Okay, now after doing this, let me again print it address of iptr here, not this part. So would you think that any difference will in these statements or not? Let me just hope you guys understand here what I am doing here. I want to see what will it do, what statement it will, what it will do. I want to increment the value of x by using the iptr pointer. So what this statement will do. Okay, so let me just see it. You can see nothing is happening actually. Okay, so both the value print just the value of this part address, means actually it is plus plus is right operator. So iptr value is first incremented here. Okay, to give the better idea, let me just give one statement percentile d slash n. Suppose I just print here value at iptr. Now we'll get the point here what this statement is doing actually. Okay, it's printing the address here. It should not be case here. It should print the value here actually. It's printing something else here. Okay, just print it this part. So it will remain 5. So it is not even incremented. So what this statement is do actually? It's doing nothing. And if I just do here value at This means value at IPTR means it should print the address. It's not doing it actually. It's printing something else here. So now let me just do one more thing here. Okay. Just do this thing. Let me see what is going to happen here. So just parenthesize this. Okay, in this part value at P. Now let's see what will happen. So again it is pointing the address part here. Okay. Now let me just use X here. It's not incremented. Again, it's not incrementing its value actually. It should not be case here. It should increment in either of this statement. Okay, let me do it one more thing here. Okay, instead of this, what if I use this? Let me see now. Yeah, you can see it incremented the pointer variable by 2 here actually. If I print IPTR, what will happen? Now it's working. Okay, it was wrong statement actually. Okay, I get it now. So it was wrong statement to increment the pointer variable, you know, increment actually IPTR value. So value at IPTR is becoming now becomes 7. So what does this do? Is increment the actually it's 2-time increment. Okay, that's why it's 7, returning 7. Let me see now. Okay, yeah. So you can see the 6 is been printed now because the IPTR value is incremented here. Value at IPTR means it is operated from right to left. So it will first take the value IPTR. Let me just give you from here. Okay. So what is actually doing here means plus value at IPTR. So now first of all it will operate from right to left. So suppose now it will give to value at IPTR. Value at IPTR is means address of X. Means address of value of IPTR is value at actually this you remember this is the way of expanding the form. Value at X is 5. So value of X value of this means 5 value. To 5 value will increment it first. Okay. And then we are printing the value. So 5 is incremented and becomes 6. Okay. So one thing you should clear that both this statement, this part and this part is same value. So hope you get this point because it will operate from left to right. Okay. So let me just print this. Okay. Let me just don't do anything. Okay. What will it print? So you can see the address is printed now. Okay. This is different value. Why address is printed? Because IPTR value is now incremented. IPTR is have value something, means IPTR. We are just making IPTR. IPTR have some pointer value. Suppose it has some value like 200, and pointer value is something. It will have address of X. Okay, actually. So now whenever I use this part, okay, means P plus. So P will increment it first because it is operating for right to left. So P will be incremented first. So P will have some address. So value P have some address. Okay. Means what does this mean actually? Let me show you to quote from. So value IPTR is plus. IPTR is pointing to address of X. Okay. Now IPTR is being incremented. So IPTR is actually have address of X. So address of X is now incremented. And incremented value might not be the continuous value we are getting it because we are dealing with the pointers here, memory here. So we might get some different value here. Okay. So better to take care of this thing. Okay. If you want to use post increment, just always use parenthesis here. Okay. Now it will work properly then only. Okay. So now let me show you the output. It will 0.76. So yeah, this is the case. Now you get this point, and in part of pre-increment, actually it does not make any difference because it will operate always from right to left. So it will value always reach its value IPTR, then increment this. But whenever you using this part without parenthesis, then it is operating the plus part, and IPTR is value is being incremented, and then the value of IPTR is getting. So this is giving some random value which is not we want, because it's pointing some other memory part location, and that gives some value which will obviously have some garbage value. So in that case, this is the case here. Okay, this is the case here. Hope you are understanding now. Hope it's very difficult to understand, so try to understand this part. Okay, now value of IPTR. Suppose what I could do. Suppose just hope you understand this. So now I can erase this. So now I hope if I use float here, what will happen? Let me see the output. So you can see this making it 0. Now you could understand the pointer arithmetic from this statement all along. First line is value at IPTR, which is address of x. Second line is value of IPTR, which is I do it twice time. Let me just don't do that. Address of x should be same, not should be different. So what is happening here? That address, oh okay, this line is address of IPTR and this line is actually address of x. So it will obviously have different value because x and y, x and IPTR have different value and different location. Okay, so that's why you're getting it. Now my point is, why you getting 0 here? My question is, why you getting 0 here actually? Because of pointer arithmetic part here. Okay, you can see the warning here also, which I have told you that it will give some warning, but it will not error actually. So very essential, whatever value wire initializing the pointer must declare the same value because of pointer arithmetic part. You can see that it is not working now. It should be incremented, 5 should be incremented and make it, it should give the output 6, but it's not happening here. Why? Because of that part, because of pointer arithmetic part. Okay, because we are declaring is float variable, so it is confused that what type of operation we have to perform on x actually on this pointer. Because of that, it is giving some garbage value. So always to use print same data type here. Okay, so hope this is clear to you guys. Now you can see it is incremented. So from practical examples, you can see the difference of different way of operating with pointers. So hope this some plate is clear, points are clear in this video. So it is you might not be understanding it before without you doing it practically at your own system. So please try it by your own. Okay, if you face any problem, please write in the comment section. I will reply it. I will clear your doubt. So this is actually happening here. This is the case of pointer arithmetic. Okay, so hope this is clear to you guys. Okay, and some other things also, that pointer value can be assigned. It can be assigned means what I am saying means, suppose I declare here another pointer variable IPTR, and it will just make it at IPTR. What will happen if I just write IPTR and I print? Don't need of printing address here. Okay, we are dealing with values actually, so just leave it. And now I just print percentile d/n value at IPTR. So what do you think? This will give same value or different value? This is the assignment of pointer, assignment operation. Okay, on pointers. So hope what will this give the output? It should be same. So yeah, you can see both value is same. So you can assign pointer to a same variable. What if I use float here? Can I do this? Think about it. It must say warning and then give some weird value. Okay, so you cannot do this. For assignment also, we can only assign to a pointer to a similar pointer type. Okay, so very essential. Note this point. Okay, now it will give perfect value. You can see that. Okay, so practical example I am showing you that by running code you are learning here. Okay, it's an interesting way to learn rather than just giving the theory, giving all the theories to you. So it is very easier if you learn from the coding part here, coding example, and you do practice it on your own. Okay, so it will give better understanding. So now moving on, let me use some functions here now. Let me work on pointers functions. Okay, so hope it's clear to you now. This pointer arithmetic is clear to you guys. Okay, always use the same data type on pointers. Don't forget it. Okay, this is the internal way I have shown you. Okay, now let me just moving on now. Let me just now work on function. So function, let me just design a function of swapping two numbers. Suppose we have two numbers, int a, int b, which have the values of something like 8 and 5. Suppose now we want to interchange this value. What do we want to do here actually? We want to print when the value, so it will become 5 and it will become 8. So first of all I will print. So first program will do the print the value of a and b. The a value will print at 8 and 5. So after swapping, the value must print. We should get this output. So now swapping function, we are designing some swapping function. Okay, swap, and this function will what it will do? It will just swap this value. So now let me see how we can implement this. So pause the video for a moment and try to implement by yourself. Okay, and so hope you have implemented it. Now let me show you my way. Okay, let me show you how it can give some weird value. Okay, actually, so let me just design that part. So suppose void swap, let me design this function int comma int and call this function int a, declare a variable here int a equal to 8 and int b equal to 5. Okay, and just call the swap function and pass those values. So first of all, just print before swapping it. Before swapping value, percent ID, percent ID, A comma B. Let me just do this first. Okay, no definition is okay. Let me just give pseudo definition here. Void swap int A int B something. This is function declaration here. Okay, it will now work fine. So you can see before swapping value is 8 and 5. Okay, it is clear. It's orientation. Okay, so before swapping values of A and B are 8 and 5. Okay, of A and B are A equal to this and B equal to this. Okay, so pending value of A and B are this. Okay, hope you are getting this point. Pending value of A and B are 8 and 5. Okay, so now let me write the code for swap function, so it will swap the value. So for that, let me use 3 variables. Second part, declare temporary variable and put the value of A here. Hope you all know the value. I have done this code also in function part also. Okay, so and B equal to A equal to B and B equal to temp. So it should, what should it should do? It should return, it should actually swap the value. Now let's see, are we able to swap it or not? Are this function able to swap it or not? So just print the same thing and make it after. So what do you think it will return? It should return 5 and 8. Okay, this is returning here 8 and 5. Okay, and this should also return 8 or 5 or not, 5 or 8 or not, because we are actually swapping those values. Okay, now let's see it is giving us right value or not. I should use slash n here also. So you can see the values are not changing. It is not swapping. What is happening here? Why it's not swapping the value? I am also written the function of swap, but it's not swapping the values. So this is the interesting thing, and in this part pointers come very handy. Okay, so let me show you how you can do that. Let me explain you in whiteboard. Okay, let me just first explain it whiteboard. So C++ actually, C language actually, C language it is using call by value. Call by value. So whenever just we write some function here or write some main function here, and main function is, you all know, where space is allocated in memory. For that part, memory is allocated in some heap or a stack, something somewhere to main memory. So whenever main memory, suppose main function is declared as A and B, so it will allocate some value of A and B in some part of memory here. Okay, A B. Now whenever you call a function calling, suppose swap function, in swap function part, for each function calling, we use stack here. So main function calling will have the space of A and B here onward, and for swap value, this is swap and this is main function. So swap will have some different copies of them, same values. Means swap will actually work like this. So whenever you declare swap function here, so swap will have its different copy of variable. So swap function have different copy of variable A and B, and it will have the value 8 and 5 and 8 and 5. So actually whenever swap function is working here, we're actually swapping the values of this part only, this stack only, this memory part. Okay, so it will actually it will definitely be swap. It will have 5 and it will add 8, but in the main function nothing has happened, because it is different copy and this is different copy. So to work with this, there are two ways to work without using pointer. What you could do, just write the print statement in the swap function itself. So it will now print the value. Okay, now let me show you that part now, and after that I will show you the pointer part. So let me just show you now. Instead of using this, what if I use this part here? Now it will, you can see the difference here. Okay, it will work now. You can see the swap value as in swap. Okay, so it is one way of doing it. Okay, but it's not satisfying the property of functioning here, function swap here. We just go into the swap function and just printing the value. It's not seems like interesting way to do. So what could be the other way around? Okay, you could do that. Nothing wrong with that. but you are not using the properties of pointers here, functions here. Okay, so now make it remain it here. Now do one thing here. Instead of passing the values, just pass the address. What will then happen here? And some interesting thing will happen. You will see that. And just make this variable as pointer variable. Value of a, in value of a, put the value of b. Now you have to use this asterisk sign. So what will it do? It will definitely swap this value. Okay, let me show you that. If you don't believe me, let me show you. Yeah, you can see the value have been swapped. So how this happened now? Just using a flick of I just use pointers here and just swap the values actually eventually. In earlier it was not happening. So what is happening inside it? So let me now explain this. Okay, so what is happening now? Okay, you will understand now. You can, it is an interesting thing, it's none there. So now what we are doing here, swap function. In this swap function I am just passing the address of two value. Okay, it's clear. And so it's things will be done same thing here, but with one difference. Okay, you will understand that. Suppose this is a stack for swap function, and this is a stack of main function. So main function will create its own value. Okay, a and b, some address 10 20 suppose. And now what is the property here? So when swap function will definitely call a variable, definitely call is in own data structure, which is own space provided. But one thing it will do, this because of this ampersand sign and the pointer variable using swap function. So void swap, let me write the definition. So this is the definition here. Okay, property is visible. So what is actually happening here? So it is now pointer variable. So it will have the pointing to variable this. So whenever a and b declared is here, okay, so it will point to its parent value, the address of the top variable. So in this way it will point to the data type, to the address, to the memory allocated in main memory, which will have 8 and 5. Now it will work on pointer variable. So value of a will be 8 and 5, but swap operation is done in addressing mode here. Okay, so pointer wise, so it will now swap it. The value will now swap. It will become 5 and it will become 8, and it will also reflected in this part or not. Why this will reflected? Because it's pointing variable now. A and b are now pointers. So we are dealing with value of a. When value of a is what? Value of a is what? The value of a variable which is present in main function. It will work on that. So if this is not clear to you, just change the variable. Okay, it might be confusing to you. Use the same variable. Okay, so just use, nothing will happen here, nothing will matter, but just for sake of complete understanding part, just change the variable here. Okay, so you can see that nothing will change, still getting the swapped value, but in this way it will be easier to explain you. Okay, just make it a x and y. So now it is x and y. So x is actually, it is x here, x y temp. So x and value. So x will have the, so x is what? X is pointing to value a, and y is pointing to value b. So whatever value is a and b, now x and y will have the same copy of this value. Okay, because this is pointer variable. So when whatever we change made in the swap function, okay, so whatever value we made change in the swap function, it will be reflected back on the main function part. Why? Because it's now pointer variable. It is actually now storing the address. So it will eventually, what will it do? It will just swap the value in the original a and b of main function. Okay, so just make this clear, make it clear from this diagram. In this way swap function will work. It will have some value and it is now pointing. Okay, so now let me just make a clear diagram here. So what is happening here actually? Let me just give you a big diagram. Okay, so if this is ambiguous to you, it will design it for you again. Now I am using bigger diagram representation. This is for swap function, this is for main function, and it will have its own data allocated in a stack, and x is pointed to y, so it will point to this variable, and this will point to this variable, and which will have some address 10 and 20. So it will have the value 8 and 5 in main function. So you can see there is some connection made, and because of the connection, swapping function is now perfectly working fine. Although they have two different copy, 1 2. So it will have now again the 8 and 5 value, because this value of x will be what? Value of x is address of a. So it will just value and y. If you write just value of x, so value of address of A. So now if you swap these the things here 5 and 7, so it is actually swap in this variable part. Okay, it will also swap in this part. Why? Because it's just a pointer variable, so there is some one connection made, and which is very essential. It will be now this connection will be very essential when I will deal with linked list and other trees also. So now we can understand it from there. This is the usage of pointers. Okay, you can just make value change at anywhere without physically being present at this space. You can swap the value of other space, means work on other field which are not present in the same space by use of pointer. Okay, so hope this is clear to you guys. Okay, and the code is also clear. So that was all, guys. Hope you understand all the parts which I have explained it here. So in this video I try my best to give you the practical solution of pointers via codes. So hope this is clear to you guys. And in the next lecture I will deal with pointer with function, pointer with array. Okay, it is the most important things, and it will very essential in many way when you will learn new data structure algorithms in your further part. Okay, so this tactics of programming of pointers with array will be helpful in futures. Okay, so those lectures will be very much interesting and important also, so try to focus on that part. Okay? And I will do both theory and practical, so that everything will be clear to you. So hope you like this video. So thanks for watching. See you soon. Take care.